Finding the variance for a sample mean, a sample being part of a population, is really similar to finding the variance for the population mean, but of course there are a few slight differences. The first being that the variance is now denoted by s squared instead of sigma squared. S stands for sample. Another difference in the equation is that instead of mu, we have x bar, which is the symbol for a sample mean, as you've already learned. Although it's a different symbol, we calculate it the same way we would with mu. They just mean different things. Lastly, instead of dividing the equation by n, we divide the equation by n minus 1. We divide by n minus 1 because it turns out that if we average the sample variances for all possible samples, it is equal to the population variance. This way, the sample variance would be an unbiased estimate of the population variance. So here we have the same data that we used in the last video, but now we're assuming that it's for a sample, not a population. We calculate the sample mean the same way, and clearly it should still be 51.2, but now it is x bar instead of mu. We calculate the sample variance exactly the same way, except that we divide by 9 instead of 10, because we divide by n minus 1, and n was still 10. Doing this, we get 102.4, which is kind of close to 92.16, but you're always going to be a little off because it's a sample. Standard deviation is still pretty much the same, except now it is denoted as s, and its equation is the square root of the equation for the sample variance. To find the sample standard deviation, we square root the sample variance like we did in the last video, and this time we should get 10.1193 rounded.